Hello everyone and welcome to part 1 to my Blitz basic tutorials. This is actually a remake of my original part 1 since I just recently saw it and I didn't like it at all, so plan to do a lot better with this one and hopefully a little bit smoother. I actually plan to remake several of my tutorials and kind of give a little bit smoother demonstration of how to make things work. Anyway, in an earlier tutorial that I won't be remaking called part 0, I kind of teach how to navigate and what each little icon does, so you can go back to that just to familiarize yourself with Blitz Basic. I'll be going over some icons, but not all. What I teach works with Blitz Basic, Blitz Plus, and Blitz 3D. I'll be using the Blitz 3D compiler. What makes Blitz 3D different to all the others is the fact that you can use 3D and upload 3D models. And I'll definitely be going over 3D modeling and all that good stuff. I mean, not 3D modeling, but how to upload 3D models in a later tutorial. Alright, so let's begin. In order to get started, we want to push this little paper-like thing and it'll open up a new source file. Here we'll be typing in all of our code. Let me enlarge the font a little bit. There we go, so everyone can see it. What I'll be going over today is a couple loops and how to really set up and what most of your programs should look like. Most all programs consist of variables, which definitely will be in this program, and loops. Those are two very important things when you do programming. Another important thing that I'll be quickly going over is comments. In order to start a comment, you want to set it up with a semicolon, just like that. Comments are completely ignored by the compiler. So when you try to run your program, it won't even read the comments. Comments are for you. They give you little notes, remind you of things. Maybe you can do like a to-do list. So this is a comment, and that's just all there is to it. Type whatever you want right there. Alright, now let's actually get something to show up on the screen. The first thing I'll be showing you is the while loop. One thing about loops is there's always a start to it, and if you type in the code properly, it should shine blue like this. Comment should shine gold. If you're using Blitz Basic or Blitz Plus, it's actually the while that should shine gold, and this should shine green. Forgot the color's a little different. I just remembered. But yeah, if they're shining different colors and they're not white like this, then you're fine. But anyway, like I was saying, each loop has a beginning and has an end. So this is the beginning of the while loop, and this is called the while loop. So while loop. The end of the while loop ends like this, just WN or when, whatever you want to call it. I guess that basically means when this ends, while it's going, when it ends. Never thought of it that way. Anyway, so that's the while loop. What you want to do in order to make the while loop actually work is you put in a statement right here, what causes this loop to work. In order to have loops actually work, there has to be some type of cause, and then inside is the effect. So up here is the cause, down here is the effect. So let's put right here, this is the cause. You can type this with me if you want, just so you can remember. Down here, whatever's in the middle between here and here is the effect. Oop. Okay. Whatever we put inside here, it'll be looping, which means it'll go from the top, go to the bottom. Once it's the bottom, it goes back up to the top. And it reads it just like a book. It starts from the left, just as we read in a book. As you're reading this, while, cause, effect, whatever. It starts from the left, reads to the right, and then goes down to the next line until there's nothing there. So it goes here, it's going to read, ignore the comments, go down here, go down here, and down here, and once it hits this part, it goes back up. And so that's the basic loop. We have to have something work, so I'm going to teach you a couple more commands. So let's do this. Actually, let's introduce variables. It's actually a key thing to introduce. A variable will shine white. So name your variable whatever you want. Anything that's white in my code, if you can, just for practice, name it something else. Don't name it what I name, but you know, it's really up to you. Maybe the first time you want to name it the exact same thing I do, but as you go back to your code and create your own game, try naming your variable something else, just so you can get used to how variables work. Alright, so let's try this. While, let's just call it number. While number equals 0. Now, one thing about variables and how they work. Like I said, it should shine white. Any variable that's actually created in the program is saved. and it always starts at 0 unless you say so. So this variable automatically is going to be 0, and because it's 0, it's going to keep on looping. So if we run it right now, it's just going to give us a black screen, and there's no way to actually get out of it, because we actually, when you're doing coding, you actually have to create a way out of a loop, create a way in a loop. Everything has to be typed in. The computer won't just assume things at all, especially when you're typing with programming. That's what makes programming kind of frustrating, is the fact that the computer doesn't assume things. So if you make a mistake, you have to fix it. The computer won't fix it for you. Alright, so moving back to the code, and getting past a couple of those laws of coding. We got this down, so now when we run it, it'll actually work, but let's not get there quite yet. One important thing that I do need to teach is called the key hit, and that's putting an input. And what I mean by putting an input is you hit something from the keyboard and cause it to make an effect on the program. So in order to find our key codes, we want to go to the help button or the home button. Either one of these will work. Go to command reference. Then one of our most important parts, our best friend basically, is the scan code picker. There we go. Here it is. And this will give you all your scan codes. So if you click it, there's 2, there's 3. One that's really easy to remember is the escape. There we go, it's just 1, basic 1. So if key hit, let's just type in 1. In the parentheses, you put any scan code that you want. You can choose a different one if you want. You can choose that one, 1. So it means if you push the 1 button, something will happen. And what this little chunk of code is going to do is we want to make whatever button we push exit out of this loop, so that way the program can close. So this close the program. So once again, I'm using comments, so it tells me what this chunk of code does. Alright, so here we go. And another loop I'll be teaching you is the if loop. There's the beginning. The if right here, it should shine blue, as it does for me, a light blue. And the end of the if statement is the end if. Pretty simple. It's an and and an if. So if that's pushed, then we want to change this number so that way we can exit out of the while loop. And that'll make sense once we execute this program. Let's just you can make the number actually equal whatever you want it to be. 1. So let's go over this real quick before we run it. Actually, you know what? Let's run it first, just so you can see how it is to run your first program. In order to run the program, you want to push this little rocket right here. It'll compile your code by putting in a little. One last thing I forgot to tell you: make sure your debug enabled is enabled. Make sure there's a little check mark right there. What that does is if there's any problem in your code, it'll locate where the problem is that's causing the code to cause an error, and you can go back to it and fix it. If that's not check marked, it'll basically just say, it'll just throw in a box that just says there's an error or there's a crash, or it'll have some type of message pop up, but it won't help you by telling you where there could be a mistake. So for now, keep that check marked. Actually, for now until way later into my tutorials, when you're actually done with your game, you want to take this off. And the reason why you ever want to do that is actually to create an executable, which actually creates an actual game. Supposedly, if you leave this on, it slows down the process. Not sure why, but it just does. So, but we're not that far yet, so don't worry about it. Just basically keep that check mark. Anyway, so let's run it. So we want to hit that little rocket right there. And there we have it. We have just a basic little box. If you're working with Blitz Basic or Blitz Plus, you don't have this right here, so you can't minimize and you can't exit out. It's basically just a box. For me, I can just close out, but that doesn't demonstrate what I want to show you. So here, let me go take out my keyboard. There we go, on-screen keyboard. And let me show you and demonstrate that, oh come on, there we go. By pushing the escape button, it'll close down our program. There we go. Program has ended. While the debug enabled is on, which is that right there, debug enabled, this little message will pop up. If that's turned off, this message won't pop up. But, you know, and I think for Blitz Plus it doesn't do that, but just deal with it for right now. If it's annoying, whatever. It tells you all sorts of strange messages. One thing I want to go over is, let's run this again. When you have the debugger enabled, you have all sorts of little commands right here. This closes it. So let's just say your program completely freezes for whatever reason, and there's no way out of it, and the escape button doesn't work at all. You keep on clicking it, nothing's happening. You can use this close button right here, and it'll completely just shut it. What this allows you to do, you can stop its execution and kind of go through the code. I don't think there's anything you can really do with it except for just kind of see where it is. Right now it's checking. The reason why this is highlighted is because it's waiting for the player or the person or the user to push the escape key. And this actually tells you exactly where the compiler is, where it's checking. So it's checking, it's waiting for a player to push that. So let's now go exit our program. Oh, right. We want to push the go button first. Right there. A little message will pop up. There we go. Alright, so let me explain how this if statement exactly works. Basically, it's checking if this is going to happen. It won't even read what's between it, to tell you the truth. It'll just stick right here, waiting for the player to push it. Anything in between here, it'll actually skip over as it's reading. But like I said, it starts from the top right here, goes down, goes to here, checks if there's anything else, and then goes back up, and then checks all the if statements. And it checks them in order, so we can have another if statement, and it'll check this one first, and then check that one, and then the next one, and next one. And it only reads the center of, or whatever's in between the if and the end if the if statement is true and there's something written down here. So if this becomes true, it'll actually read it and do whatever it does. And the reason why it's closing is because this loop only runs if number equals 0. I made number equal 1. And remember, whatever we cause this to be, call it. Hey, it could be anything you want. It has no magic, doesn't do anything special. Anything that's white just has no effect at all. Hey has to be that. Whoop. If we name this anything else, it won't have an effect on the program at all. And let me show you what happens. Let's just call it gosh, or whatever you want to call it. Let me run the program. Bring on our on-screen keyboard again, and we need there we go. If we push escape, it does absolutely nothing. So that's where we're going to need this little quick end button, or whatever you want to call it. I don't know if it actually has a name, but kind of like in a fire escape, an explosion, whatever you want to call it. It'll close it since there's no way out of it. So that right there has a really good use in case there's any type of crash or anything bad going on. You have a quick escape. Alright, so let's put this back to hey. Alright, so our program's not very exciting right now, so let's kind of like spice it up a bit. Let's put something to display on the screen. So let's type in the word print. It's a basic thing. I don't like to use it, but just for demonstration, we'll use it right now. You might like it. And type in whatever you want. Inside quote, make sure you put inside quotes. Print will basically print whatever you tell it to print onto the screen. It could be numbers, it could be anything. Whatever's in between the quotations. And it'll print right at the top left corner. And there it is. And it's going to endlessly just type in hello, because the reason why is because we're in a loop and it's endlessly looping. Just going back to the top, like I said. So I'm going and going and going and going. So there we go. Remember. Good. Escape. There we go. It's a little annoying runtime message. And there's print. One I enjoy using is something called text. A little different. Text, you get to actually choose the point that you could put your little message. And we'll go into plotting and all that good stuff in the next video. But we type in just for demonstration purposes. There it is, just hello. And it's not making a long list because it's only texting it at one point. It's actually making 1,000,000 hellos, but they're just on top of each other, so it's hard to tell. And it goes so dang fast, you can't even see any type of flicker or anything going on. But yeah, that's how fast how theirs can run. Real fast before we cap up this video, I want to type in or show you how to actually kind of change the resolution, since our box seems to be a small little box, and what fun of a game is going to be in a tiny little box like this? We want to have kind of some space in our game. So in order to do that, we type in the word graphics, just like that. And we choose our resolution. The most common resolution right now is, could be wrong, yeah, it's 1024 by 768. And that should look something like this. There we go. Nice big screen. On my screen, it's going to look a little smaller because my screen's actually bigger than the average 1024 by 768. Most computers now have a wider range, but the reason why this is the most common is because 99% of computers use this resolution now. It used to be 800 by 600, but that is no longer the case. I used to think that, but according to statistics, it shows that this is now the most commonly used resolution. Now, there's a couple other things we can do with this. A couple cool things we could do. This basically just sets up the boundaries. It's a number right now, and it's basically perfect right now, but we can actually kind of change the size. We can make it full screen, so it goes from corner to corner to corner. We can make it so that way we can kind of stretch it, and we can make it so it always remains this size and never can change. See, right here we can't actually maximize it. There's a way to maximize it. So let's type in a 0, and what the 0 means, it's the color bytes. And to be honest, the compiler ignores this, so I don't know why it asks for it, but basically if it's 0, it goes by default of having all colors, which I think is 256 or something. I totally forget. I am sorry for that. You can type in like 16, which I think like only basic red, blue, green, yellow, all that stuff, but still the computer ignores it. It goes to the best that your graphics card can go. So you can even have some neon colors if you know how to put that inside your code. I remember reading that 1 and 2 was like black and white. Well, let's just put 0 because it won't make a difference no matter what you put. And this next one, I'm going to put this next number is actually the important number. I'm going to put in a 2 for right now, but there's different numbers. 1 is full screen, fills up the entire screen of your computer. Got to put it down because you won't be able to see it. 2 is it's going to be windowed screen, and 3 is kind of like a custom windowed screen. Now don't get too excited. It's not custom like you can change what type of screen you have. It's custom, you can like stretch it. It's probably custom stretch window screen. I don't know what to really call it, but let me actually show you. So 2 is basically what we just had. Just that. Still good practice to put that 2 in. If that's the only resolution you want. 1 is full screen, and 3 is a stretch screen, so we can stretch it. Yep, see? You can mess with all this right here. And if you're using Blitz Plus, this is the only way you can get this to show up. Blitz Basic, I can't remember. I believe, yeah, it's the same thing. Actually, you know what? I don't even know if Blitz Basic actually supports these numbers right here. I think that actually came afterwards when they made Blitz Plus. But if anything, you're not really missing out on a whole lot if you're just going to stick with a basic resolution. Just don't worry about it. But mostly, most people who are probably watching this, they're probably using Blitz Plus, Blitz 3, one of those. Blitz Basic is basically out of style now, from what I understand too. So there we go. I'm not going to show full screen. You can try it out, but I've had problems with full screen while I'm recording with Cam Studio, since Cam Studio is kind of like a generic type of thing. It works really well for me, but I mean, it still has a couple problems, but it's the best I have right now. But I've had problems where I put a 1 full screen, ran it, and completely just messed up the sound. But yeah, if you want to see what full screen is, it's basically just fills up your whole screen. You don't even see this bar right here, down here. You won't see that bar at all. Most computer games actually go by full screen. If you're doing like a hardcore ones, if you're doing like a simple one, you probably want just a windowed screen. Alright, so that's enough on that. Put that to 2 because that's what I used to like. Me personally, I use a strange type of resolution, and I'm going to show you why, actually. I don't like doing 1024 because it's not I don't know, just because it's strange for me. I don't know why. I'm sorry, but the reason why I kind of shrink this right here, which I'll show in a second, is because as you can see, if I'm working with the game, you can't see the bottom because my screen is exactly 768, and this bar gets in the way. So the bottom's right there, but like I said, it's perfectly 768, so I can't ever see the bottom. So I work with this 600, sometimes 650. That was my 600. So there you go. And the way to read it, like I just said, it's 1005. That so the 1000 works from the top, 600 works from the side. So there you go. So X and Y, which I'll go more in depth with coordinates and stuff like that in a later video. Actually, probably next video. Depends on how I'm going to order this. Alright, one last thing I'm going to go over real quick is between what this is called actually excuse me, main loop, and this is where all your main functions going. Main loop right there, and this is basically like the header of your program. Anything that goes on between here is read only once because there's no loop, but the computer will still read it. You don't need a loop to make the computer read things or remember things because everything goes straight into your RAM. So any variables you set up, the computer will remember it in its RAM. And most people's RAM goes up to 2 gigs. So really, with everything I teach you, I have nothing to worry about running out of space on your computer because trust me, 2 gigs is more than enough for the computer to have its disposal. For me, I have a you know, I don't even remember, 4 gigs of RAM or something, maybe a little more, maybe quite a bit, I can't remember. This is kind of a newer type of laptop I'm working on. But anyways, so let's say we create the variable hey earlier, and we make it like -1. If we run it, the program's going to close right away because hey doesn't equal 0. There, closes. And like I said, any variable that's entered right here, the computer right away from just seeing that's going to remember it, put it into its RAM, always equals 0 unless you say so. So I said so right here that it equals to -1, so it's not even going to say hello as far as I know. Yep, see, it doesn't even show it. Doesn't even get that far. It just shows that, oh, it doesn't equal 0, hey doesn't equal 0, so I'm going to skip over down here. Oh, there's nothing down here, so we're just going to end this program. There's nothing to run. So that's how a compiler works in a nutshell. And that's what makes loops really, really well done. One cool thing though is since we learned what a key hit command does, and these are what are actually called functions, but I like to call them command. Functions are usually in a light blue for Blitz 3D. It's basically a command, and it has parentheses, and something will go into the parentheses that it'll like use to make it work. For this, in this case, we're using a key hit, and a scan code goes inside here. So like I said, if you go back here to the little help thing, any of the scan codes work. It's all right here. And once again, in order to get there, home button right here. Command reference. Oh, there's another one, a list of them, but I like using the interactive one where I can click on the buttons. A little bit more fun. Okay, anyway, what we can do is we can actually delete all this. What am I doing? And instead of putting a variable to hold on to the loop, we can have if while not, which means not means it's not true, key hit escape key. And another thing we can actually do is escape equals 1. Put it up there, showing that escape equals 1. So it knows that escape is 1, which is that. That makes sense. Escape will always equal 1. Put escape in here. You can put variables inside here, inside the parentheses. And basically what this means is while the user does not push the escape key, this will continue to run. So we go. We got hello there. Alright, before we cap this up, which I really want to go over, there's a couple things I wish to go over, but maybe in the next video. Type in right here, which I didn't bring up, is a flip. And that is very important. Flip basically flips whatever you want to show onto the screen. Basically flips it like a flip book. So we put flip down there. Without it, sometimes if you get lucky, it'll show up some stuff, but without it, a lot of times things you want to show up on the screen won't even show up. And so if you run it, there we go, we got hello, and you know what? There wasn't even a delay in it. It just showed up right away. So let me show you the difference. We get rid of flip by commenting it out, and it takes a little while to show up. I mean, it's kind of quick, but you can kind of catch it if you pay attention. But flip basically flips absolutely everything you need on the screen onto the screen. Another thing we want to do is clear the screen right here. So let's see. Flips text and images, so it's very important when you have images onto the screen. The next thing I'm going to also teach is clear the screen. The clear the screen command, CLS, which is just clear screen. The reason why you'd want to do that is because, like I said, it works kind of like a flip book, but a different type of flip book. Running it really won't make a difference. So just say hello still, but say you're having like an image move across the screen. If you don't have this clear screen here, it'll actually leave kind of a streak of the player going across the screen. And I'll demonstrate that when we're going into images. But for right now, just put that down. Make it a good practice to have your original program look just like this. And this is what almost all programs should look like. Another thing, if you're working with Blitz 3D, which you definitely do need, and if you're working with images, you can't miss this, is the set buffer command right here. The back buffer. Now what a buffer is basically an image that you're putting onto the screen. You're setting up the buffer, which means you're going to set all the newly drawn images to the back. Right here, what we're looking at is a front buffer. The back buffer is images it's setting up beforehand. So basically, the computer sets up the next image before it flips onto the screen in the background. Kind of into memory, it's creating it and flips it, and all these different types of possibilities. It's just drawing in the background, getting ready to flip them at any time. This will come into play a little later. It probably doesn't make sense right now, but just something to keep in mind. But basically, Blitz 3D users, all this right here, we'll accept the comments, but basically all this is how every program should look on it, also except for this too. This is kind of you know, a little simple thing we just put in. But anyway, basically you want the while loop, clear the screen, flip the screen, end it, all this good old stuff. Alright, and that's it for today. I hope you enjoyed, and hopefully you'll stay with us. Part 2 is already made, but it's an older part 2. And it might not follow along with what I'm doing since I'm going at kind of a different pace. But be sure to check out my other videos if you don't want to wait for a new part 2. And thank you for staying with me, and I hope to see you in my next video.